Hi everyone! Welcome to my YouTube channel. Hi everyone! Good day! I am Rose Vidores de Rosario, a BS Ed Math student from Kapalong College of Agriculture Sciences and Technology. This video contains linear programming topic. So what is linear programming? Linear programming is a mathematical modeling technique in which a linear function is maximized or minimized when subjected to various constraints. This technique has been useful for guiding quantitative decisions in business planning, in industrial engineering, and to a lesser extent in the social and physical sciences. Today, we are going to tackle about how to solve a linear programming problem using a graphical method. Now, let us look at the setting. First, produce a list of products with selling prices. Uses a list of raw materials, capital, labor, and etc. Then maximize profit using limited resources and minimize cost meeting the production requirement. Our goal for this is proper modeling. There are two types of banana snacks, the banana Q and ginanggang. The resources needed for these snacks are banana, sugar, and cooking time. So for banana Q, we need 20 kilos of banana, while ginanggang, we need 40 kilos. Sugar, we need 2 kilos for banana Q and 1 kilo for ginanggang. And for the cooking time, banana Q will be cooked in 45 minutes, while ginanggang will be cooked in 3 minutes. For the maximum limit, banana will have 500 kilos, sugar 5 kilos, then cooking time 60 minutes. So now we will create a mathematical model for this problem. So our variable are x and y. So gain or profit function to maximize f of x and y is equal to 40x plus 50y. Subject to constraints are banana 20x plus 40y is less than or greater than 500. Sugar 2x plus y is less than or equal to 5. For cooking time, 45x plus 3y is less than or equal to 60. And x and y is greater than to 0. Now, let's find the value of x and y for this. Let's start with the banana. 20x plus 40y is less than or equal to 500. Let x be equal to 0, so 20 times 0 is cancelled out. Now we have 40y is less than or equal to 500. Divide both sides by 40 in order to get our y. So now our y is less than 12.5. So next our x, the same process, 20x plus 40y is less than or equal to 500. This time, our y will be equal to 0. So 40y will be cancelled. The remaining term is 20x is less than or equal to 500. Divide both sides by 20, so our x is less than or equal to 25. Okay, we'll find the value of x and y for the sugar. So we will execute the same process. So the value of our x is less than or equal to 2.5, and the value of our y is less than or equal to 5. Then for the cooking time, x is less than or equal to 1.33, and y is less than or equal to 20. Next, we will substitute the value of x and y to our objective function in order for us to find our optimal solution, which is 500 at point x is equal to 25 and y is equal to 12.5. Next, let's plot the points of our constraints in a graph. So we can see it in the presentation, and then if all the constraints put in one graph, we can see an intersection, and that intersections are called extreme points. In order to get that, we need to follow this process. So, first point occurs in the constraints 20x plus 40y less than or equal to 500 and 45x plus 3y is equal to 60. So we need to think of a number so that we can cancel the x and make it into 0. So in this problem, I use 12.25 multiplied to 20x plus 40y less than or equal to 500. So it resulted into 45x plus 90y is equal to 1125. And then this result is subtracted into constraints 45x plus 3y is equal to 60. So the result is negative 87y is equal to negative 1065. So in order to get our y, divide both sides by negative 87. So y is equal to 12.24. So now let's proceed in finding our x. In order to find our x, we need to substitute our new value of y into the constraints 20x plus 40y is equals to 500. So it will become 20x plus 489.6 plus is equal to 500. So we will apply the addition property of equality. We will subtract both sides by 489.6. So it will result into 20x is equal to 500 minus 489.6. Then it will come up into 20x is equal to 10.4. Divide both sides by 20. So our x is now 0.52. So for our second extreme point, we will execute the same process in order to get our x and y. So our x is equal to 1.10 and y is equal to 2.69. So let's go back to our graph. We can see now a shaded portion, which is our feasible region. So what is feasible region? A feasible region in a linear program is a set of all possible feasible solutions. An optimal solution to a linear program is the feasible solution with the largest objective function value. So the last part is we will substitute the value of our extreme points to the objective function. So first, 1.16 and 2.69 is equal to 180.9. Second is 0.52 and 12.24 is equal to 632.8. And the third is 25 and 0 is equal to 1000. And the fourth is 5 and 0, which is equal to 200. So therefore, our maximum profit is achieved at x is equal to 25 and y is equal to 0 with the profit of 1,000 pesos. That's all for our linear programming tutorial. I hope you learned something. Thank you.